So yes, I'm Kevin Daffey. I'm the president of the Marine Engineering Science and Technology, the biggest domain representative of marine engineers, science and technologies, 19,000 members globally. As a day job, I work for Rolls-Royce Group in the Marine division, but here today I'm representing the IMAREST and the considerable subject matter expertise that we have. And what I wanted to do was just sort of convey where we are with marine transportation, autonomous transportation. So let me first of all talk about UK Maritime. As an island nation, we've got a fabulous, rich maritime heritage that goes back for centuries, really. And marine trade really features heavily for us. 95% of all of our trade comes through our ports. The maritime sector represents something like 46 billion in gross value added to the economy. And it's actually larger than rail and aerospace. On the autonomous journey within marine, we have got some great successes in the UK. I mean, the first one is that the Maritime UK Autonomous Systems Regulatory Working Group have come together and they published the first code of practice, which was industry and globally acclaimed in 2017, and it's gone through a number of iterations. So something to be very proud of is the fact that we have been leading the way in the regulation of this technology. Next year, we'll see the Mayflower, the autonomous ship, which is a 15-meter trimaran that will cross the Atlantic completely autonomously. And again, it's a great collaboration between industry and academia coming together to demonstrate this sort of technology. On the science side of things, we've got the famous BOTE, part of the Sir David Attenborough, the National Oceanographic Centre. They're beginning to use autonomous technology to collect data from under the ice, as it were. And in the last month, the Maritime Coast Guard Agency, our flag state, has established the Maritime Autonomy Regulations Lab, which again is trying to bring together industry and facilitate the testing of this technology. The UK Royal Navy has been very successful over the last few years, bringing industry together to demonstrate the technology in its unmanned warrior program. And we do have two test sites, as it were, in the Solent and also in Portland, off of Weymouth there, that in the harbour, that we're going to be using for testing this sort of technology. So why do we want to do autonomy, and where is it going to be actually used in maritime? Well, actually, most of the focus on autonomy in the press has been about, autonomous container ships and bulkers. It's not going to happen in that domain, not for many, many years. And in fact, anything that carries a volatile cargo, it's unlikely the governments are going to get into a permissive regime to allow it. Where it really is going to become in its own is around flag state areas, around coastal waters. So inland waterways in Europe is a good candidate, and technology is beginning to be developed in this area. The transportation of coastal cargo. Tug operations is an interesting one because tugs operate in close confines of other vessels. It's quite a dangerous trade to be in, and there's been a number of deaths over the years with tugs being broached, people being injured or drowned, and actually making these remotely controlled when you're in the vicinity or connected to another large vessel is a good way of improving safety. Work boats and the offshore industry, it could really help the offshore renewables industry by getting supply boats and maintenance boats out there, crewing them without anybody on board. And certainly the offshore industry has been pretty well pioneering some of this technology in the recent years. Fishing is again another dangerous industry. And again, if we can transfer people away from the ship and put them onto shore type roles, then that's a benefit all round. On science, the scientists could really use this for underwater autonomy, collecting data samples, bringing greater amounts of data, and again, removing humans away from what can be quite dangerous scenarios, say for in the Antarctica or Arctic areas. And clearly, the naval side of the world is beginning to explore this technology, again, removing people away from the warships. Coast Guards can use them for greater search and rescue and also protection as well. Again, saving on actually sending people to sea. Of course, there's always opportunities and risks with autonomous technology. On the plus side, the real idea here with autonomy is to take roles away from the ship and put them to shore. And that has some great benefits. The offshore industry's seen this in terms of taking people into remote operations. we're actually beginning to see remote operations used by the class society to survey vessels often. The environmental case is where I've been involved with studies in the past where we've looked at the fact that you can design ships completely differently, you can get rid of all the life support systems on board, and you can actually show quite a large saving in the CO2 per ton of cargo per nautical mile, because you can effectively utilize the vessel to get more cargo on board, and with less hotel services on board, you're actually fuel saving and designing the vessel differently. It's a great outlet for technology and growing economies. And on the science side, we can collect more data in a much safer and reliable way. There are negatives to it all. We really got to learn about, how do people operate in remote centres, or if we have fewer people on board ships, we have to think of the mental well-being of those people on board when there's fewer people on board the ships. And this COVID crisis has really highlighted the issue with mental health at sea, with many, many crews, 100,000 people around the world that have been stuck on their vessels, unable to travel. And the mental health issues have been really severe in our industry. Cybersecurity is another challenge. When you begin to have lots more connected systems on shore and on ships, then the threat from actors coming along and trying to intervene is much greater. The whole regulation of autonomous ships is an area where the International Maritime Organization has set about looking at this, but it's going to probably take something like 10 years to allow autonomous vessels to operate between countries in the deep oceans. And then the final point around marine mammals is that if we produce more sensors like sonar systems, then there is a real challenge that we could have a problem with interfering with marine mammals and marine wildlife. So it's an area that we have to watch out for. What are other governments doing? Well, there is a phenomenal amount of work going on at the moment. South Korea has just announced that it's trying to develop its own ecosystem by 2025 for autonomous vessels, building remote operating centers, getting its industry and shipbuilding together to build these vessels. In Japan, transporting across land is really difficult, so they rely a lot on coastal shipping, and they struggle to get people to go to sea. So again, autonomy represents a new way in which they can access and get cargoes around their coast. China is aiming to be the world leader in the technology by 2025. It has the most patents filed at the moment, generated by its industry and academia, and so on and so on. Lots of countries are really heavily involved in investing in this technology, both in governance, in demonstrators, and setting up permissive regimes to allow this technology to be demonstrated. The final one there is the US. They've really been investing a lot of money in the naval side of autonomy with some very successful demonstrations like the Sea Hunter. And again, the US is pioneering this technology for defense applications. So if I was to make a plea to government, to the UK government, why should you invest in the knowledge and capability around autonomous systems? First of all, as a maritime nation, the UK can really capitalise on the use of its digital technologies. It can learn from other sectors, including the aerospace and the automotive sector, to really boost its economy. On the safety side, we're trying to really transfer roles from ship to shore, make sea operations inherently safer. And actually having remote operation increases the diversity in the sector, because it's really difficult to get women to go to sea and other ethnicities to go to sea. And effectively by having remote operation centres, we can bring together diverse communities to work together, and they go home to their families every single day. It's a natural technology to support our offshore renewable sector, allowing access to remote seas and very difficult waters, especially off the northwest of the UK and in the North Sea. The technology allows us to be more sustainable at shipping, reducing the CO2 emissions per ton of cargo per nautical mile, and also reduces the cost of shipping as well. And we get a greater connectivity with the ports as well. On the science side, we can enhance and collect more data in a much safer way, and the UK can continue to be a world leader in maritime, ocean and climatic sciences. And finally, the UK is a natural leader in the regulation of autonomous technology. The IMO is here in London. We've got a huge insurance, P&I clubs, we've got Lloyd's Register, and marine law as well here centred in London. So the UK is the natural home for the regulation and defining the regulation of this technology globally. So with that, Stephen, I'll throw it open to questions when you come to those later on in the discussion. Thank you.
Well, thank you for asking me along to speak today. So mine's probably a slightly curveball of a talk compared to the rest of these that are focused on autonomous transport. So I am actually a geologist and I work for a company called Cornish Lithium. So we are exploring for lithium down here in Cornwall. And lithium really is the key element to helping us decarbonise the economy. So part of our move to electric vehicles, some of those will obviously be autonomous, is all being driven by battery technology. And actually, lithium is a key component of many of these batteries. Lithium's the lightest weight metal, and it's got a really high charge density. So if you're looking for a battery to be portable and lightweight, then actually lithium's pretty key. We've got significant potential to produce it ourselves here in the UK, particularly focused on Cornwall. So today I'm going to give you a bit of a background to where we currently find lithium, the potential that we've got in the UK, and then I'll finish with a little update on what we're doing at Cornish Lithium, all in the next 9 minutes. So I wanted to start with this phrase: if something hasn't been grown, then it's been mined. Everything we use in our daily lives has come from the ground in some way or another. Take a smartphone, for example. The average smartphone that we have these days contains 2/3 of the elements from the periodic table, and those have all been mined from different mines all around the world. So there are really significant impacts associated with the production of all of these mined things. If we want to transition to a decarbonised economy, then actually we're going to have to mine a hell of a lot of raw materials to help us enable this. To put that into context, there's a stat by the World Bank that came out last year, which says that in the last 5,000 years, humanity has mined about 550 million tonnes of copper. We need to mine that same amount of copper in the next 25 years, purely for use in low carbon technologies. So this energy transition is going to be really mineral intensive, and I think it's something that hasn't necessarily been thought about in as much scope as you need to, particularly if you take into account the fact that on average in the mining industry, it can take about 10 years from finding something to actually producing it at a commercial scale. So lithium, for example, if I move on to the next slide, the World Bank actually estimate that we need 500% more battery metals by 2050 than were produced last year. I think for lithium, that's 965% more lithium by 2050 than we produced in 2019. That's really significant. Current places where lithium's produced can kind of ramp up their production, but actually it means we also need to look in places that we haven't bothered to before. So sometimes that's going to be in more remote parts of the world. Sometimes that's going to be deeper undercover. We're going to have to look deeper in the ground to find these deposits. But perversely, I also think it means we need to start to look closer to home. In Europe, we very much have this kind of not in my backyard attitude to mining. If you say that a mine's going to open up in the, down the road from your house, in a lot of cases, there's people are up in arms. They're like, think of the environmental destruction. There's going to be heavy trucks going past our house. It's dreadful. We don't want that. We will still use our mobile phones actually, and we will still drive our cars, but we just rather not think about the impacts of actually producing these raw materials. In the UK and in Europe, there is a lot of potential to produce the raw materials that we use every day in our lives. We just haven't done it because of this NIMBY attitude for the last few decades. Whereas actually, I really believe there's an increasing argument for looking closer to home, seeing what geological potential we have, and producing things to high environmental standards where workers are paid fairly. So as we transition to a decarbonised economy, we need low carbon technologies such as wind turbines, such as solar panels, batteries to store these on a grid scale and to power our autonomous vehicles. This is going to be hugely mineral intensive, so we need to start thinking about where we're going to source these from. And actually, COVID this year has really thrust into the spotlight quite how dependent we are on international supply chains. The UK is totally reliant on imports of lithium and other critical raw materials. We've got the potential to produce a significant amount of what we need ourselves here in the UK, so surely we need to start thinking about that. This is a map that's a couple of years out of date now on the left, but it shows where lithium's produced, and it's still pretty much true. It shows that the vast majority of the world's lithium either comes from South America, where it's produced in these salar brine deposits. These form in places such as the Atacama Desert, where it's very arid and you get these salty pools of water that form just beneath the surface. These are very rich in lithium. They pump them up to the top, they go into these huge evaporation ponds, which has really big environmental footprint, and over 90% of the water evaporates off to the atmosphere. So you're left with a really, really salty solution. They then form the lithium mineral concentrate from that. In really water sensitive areas such as the Atacama Desert, yes, this is a cheap way of producing lithium, but actually it's got really significant environmental and social implications. If we then look at Australia, Australia produces a large amount of the world's lithium from hard rock, from a mineral called spodumene. This has to be roasted to nearly 1,000 degrees Celsius to kind of crack the crystal structure to then allow you to leach out the lithium. That needs fossil fuels, and again, isn't that environmentally responsible. What's really key about this map is actually the lack of any significant production from North America, from Europe, from China, or from Africa. Europe is actually one of the biggest markets for lithium, and that's only going to grow as our demand for electric cars grows. But we're not producing anything ourselves at the moment. The other key thing from this slide is that actually, although at the moment most of the world's lithium is either produced in South America or Australia, they produce mineral concentrates. These mineral concentrates, more often than not, then get shipped over to China because China's developed pretty much all of the ability to produce battery quality chemicals, which means that they're capturing so much more of that supply chain. They're producing the battery quality chemicals, and they're producing the cathodes, the battery cells, the battery packs, and then that might get shipped over to Europe or the US to go into an electric car. There's the opportunity to capture so much more of that value closer to home. So why are we looking in lithium? Apologies for the resolution of this map, but this is from the US Geological Survey, and it shows key lithium deposits around the world. Most of them are red squares. These are kind of rich lithium seams in the hard rock. There are some yellow blobs though, and if you look over Cornwall, there's one yellow blob there. This is representing a bulk lithium-enriched granite. So rather than having narrow seams of lithium mineralization in Cornwall, the whole county is underlain by this big mass of granite. It stretches from Dartmoor in the east all the way out to the Isles of Scilly in the west, and it kind of forms all the topographic highs in the area. So it's a bit like the Loch Ness Monster, we say. So where it pokes out at the top, that's where you see it, but actually it's all joined up at depth. And this granite's really important for two reasons. One, it's hot, so we've got more potential for geothermal energy in Cornwall than we do in any other part of the UK. And then secondly, it's enriched in lithium. So, that's why we're looking down here. So lithium was actually first discovered in Cornwall, not in the granite itself, but in the hot springs that used to plague the deep mines. If you've ever been down to Cornwall, you'll see that there are engine houses dotted across the county. And these are here because they were dewatering the mines. So they were pumping water out to artificially lower the water table so that they could mine to deeper and deeper depths for tin and for copper. Most of that water was meteoric, so it's rainwater that kind of fallen on the top and trickled down. But actually, a significant amount of the water that they pumped out in Cornwall was what they used to call hot springs. So deeper down in the mines, they'd have these upwelling hot water springs, which are geothermal waters. In 1864, Professor Miller from King's College in London actually took a sample of some of these waters and tested them for their geochemistry, and he found that they were unusually rich in lithium. And he wrote a paper, an academic paper at the time, which basically says these hot springs could be a potential source of lithium if only we had a use for it. So fast forward 160 years, and here we are. So we are looking for lithium in two settings. One, contained within the geothermal waters, and two, actually within the granite itself. So what we do is we drill boreholes from the surface down to depth, and we intersect a number of these permeable geological faults. These permeable geological faults are really key because it's where there's space for these waters to circulate. If you think of a granite work surface in a kitchen, it's pretty solid. It's not going to have much water flowing through it. And that's why these big cracks in the Earth's crust, these geological faults that have been here for 10 to 20 million years, they're so important. So we drill down from the surface through these faults, intercept the waters that are circulating naturally, pump them up to the top. And what we'd ultimately like to do is harness that geothermal heat energy contained within them to help process the lithium out. We did some drilling over the winter. It was very cold, but we had some fantastic results. We took samples of water. We drilled 2 holes down to about 1 kilometre each, 1,000 metres. Took a number of samples, tested them for their lithium content, and now we're talking to people who've developed technology that allows you to directly extract lithium. I mentioned that in South America, they use evaporation ponds as a way of concentrating up their lithium-rich fluids. That is not going to work in Cornwall. It's really the advent of new technology that's unlocking the potential of producing lithium from geothermal waters. I'm just finishing up now, but we're also looking at potential to produce lithium from the granite itself. The places in Cornwall that have the most potential to produce lithium from the granite itself are actually within the China Clay District. So we drilled 41 holes within an existing China clay pit, and we've actually put out some very exciting news today about our collaboration with a technology provider that allows us to extract the lithium without having to roast it to 1,000 degrees, which has a much better carbon footprint. So we've also done some research funded by the Faraday Battery Challenge, looking at the feasibility of actually producing lithium in the UK to a battery quality that can then be used by the battery and car industry here. And that's just concluded, but it's been really interesting. And then finally, using life cycle assessments is a fantastic way to let you really prove the environmental credentials of what you're doing. And what we're doing here in Cornwall looks to be really positive. So thank you very much for listening to me.
So my name is David Hamson. As introduced, I'm Deputy Head of the Centre for Connected Autonomous Vehicles, which is a government unit or division which is focused on the kind of bringing about the future benefits of connected and automated vehicles. So in terms of objectives for the presentation, thanks very much for having me today. I wanted to talk a bit about ways to frame the technological innovation in automated vehicles that we're seeing. I wanted to talk about the fact that the government is, and I think needs to be focused on outcomes rather than technologies. So the technologies themselves are neutral. What we're interested in here is the outcomes that can kind of improve society, improve the way people get about and kind of quality of life. And that there are lots of potential benefits from automated technologies. And finally, I want to talk a little bit about UK strength, which has been through work between government, industry and academic partnerships over the last 5 years. So the Centre for Connected Autonomous Vehicles, so we're a government division between the Department for Business and Department for Transport. And we tend to kind of group what we do into 3 main areas. So joint investment with industry and academia in R&D and advanced trials, in an integrated testbed system, and obviously that crucial role for government in creating a clear regulatory pathway to make sure that any automated vehicles are safe and secure. I should say we're connected and autonomous vehicles together. Often those 2 technologies are grouped closely, which is why I'm talking about both. So I said I wanted to talk about what is an autonomous vehicle. Unfortunately, because of IT issues, I won't be able to show you the GIF, which is in the bottom left there, which is from a Waymo car. So Waymo, often acknowledged to be one of, if not the global leader in this area. They've been investing more and for longer than anyone else. So they're kind of part of the Alphabet group, so Google's self-driving arm. So in terms of a definition of autonomous vehicle, so there are lots of definitions bandied about. I've chosen one from a piece of UK legislation, the 2018 Automated Electric Vehicles Act, which describes an automated vehicle as may lawfully be used when driving themselves in at least some circumstances or situations. So essentially a self-driving car, which is what you see. I think kind of the general public's vision of what is a self-driving car is kind of nicely summarized by, well, this freeze frame of a GIF. There's no driver there, there's no safety driver. The car is essentially, if you were to watch the GIF, guiding itself with passengers in the back. But I think one way that I find helpful to frame the development of automated technologies is this kind of division in the bottom right. So the split between everything somewhere and something everywhere. So everything somewhere is the car will entirely drive itself. So without any kind of human intervention, or human agency, like this kind of Waymo example on the left, you can see that there's no driver there to kind of take control, but it will do so in a kind of a set series of conditions. So either it will be a set route or a set geographical area, or it won't be able to drive at, say, night or in snow or in rain. So doing everything, but within a kind of set of circumstances in which it can operate. And then the other side is the something everywhere. So we've been seeing this for years with the development of technology in the automotive industry, with driver assist systems, with lane keeping, with automated braking, and increasing technological sophistication. So the cars that everyone drive about will increasingly see technology to aid the driver and then potentially take over small tasks of the driver in specific situations. So I find that quite a useful way to frame it. There are two technological movements going on, which of course eventually will meet, but with slightly different objectives. So I said earlier that governments focus on outcomes, and I've got kind of two pictures here from the government's Future of Mobility publication in 2019. So on the top, you've got kind of future of transport heaven. The sun is shining, there's lots of active travel, there's lots of space for pedestrians and interaction. You've got shared mobility. Obviously, everything is zero tailpipe emission. And that's kind of the way that the transport system will interact. And on the bottom, you've got kind of a version of transport hell. So everyone's in their own autonomous pod. You've got lots of congestion. You've got no shared mobility or public transport. You've got no active travel. You've got increased alienation, no space for pedestrians. And obviously, it doesn't help that it's very grey. But I think it does help to focus us on the fact that we're talking about a transport system here, about how people get around rather than getting overexcited about the specific technologies and more how we harness those technologies to improve people's lives. So then a specific focus on connected and automated mobility in vehicles in particular. What benefits can they bring? So kind of set out 5 here, but so one of the chief ones is around safety and security. So 85% of accidents involve some form of human error right now. Computers don't get distracted, aren't sleepy. So there's a potential there to improve and kind of save thousands of accidents a year. Increased productivity. So there are 2 elements to this. One is around efficiency. So being able to make road use more efficient, the cars can interact with each other, respond quicker, can potentially save on the estimated 2 billion congestion costs in the UK each year. But there's also an element there about future jobs. So the well-paying, secure jobs of the future in things like coding, agile vehicle design, fleet management. We want those to come to the UK. Improved access to transport. So 25% of people in the UK, 2019, did not hold a driving license. Some of that's from preference, but also many people are not able to drive for various reasons. So you can see how self-driving vehicles could potentially open up new mobility options to people that are less well served by current mobility options. Decarbonisation of transport. I should stress that the impact of self-driving vehicles or automated autonomous transport on decarbonisation is definitely an open question and debate. It's not kind of guaranteed it will improve decarbonisation targets, but there are definitely some potential elements there in terms of efficiency of the vehicle, how it moves through cities, congestion, which could deliver real benefits to the net zero objective. And then finally, the alignment with the future transport. So again, this is key. There's a holistic transport system here where we're seeing new business models, new technologies like micromobilities and electric scooters, drones, the drive to net zero, and how this all links together with connectivity and automation, and keeping track of that and making sure these are delivered in a way that improves those transport outcomes is obviously key. So I'm just going to move on to talk a little bit about some of the things that CCAV and industry and academia have done in the past 5 years. So some major R&D trials. There are a few very exciting trials coming up in the next 2 years. So in this slide, you can see Endeavour and Serve City are both trialling in major cities in the UK, trialling those kind of high-level automated vehicles, that kind of everything somewhere. And on the left, the CAV Forth project, so a single-decker 14-mile bus service across the CAV Forth, the iconic CAV Forth road bridge in Scotland. Will be an automated bus taking the passengers with a safety driver. All of these involve safety drivers. Obviously, safety is paramount. There's some really exciting trials happening here in the UK in the next couple of years. I spoke about an integrated testbed system. So government and industry have invested over the last 5 years in a series of testing sites across the UK, all within 3 hours drive of each other, as you can see in the kind of graphic on the right. An example of one, this is Hariba Myra in Nuneaton, is on the left. So this is a kind of a large disc where you can push a vehicle to the physical limits of handling. But it's not just closed sites, there's also open sites on public road with state-of-the-art infrastructure and connectivity and simulation and modelling to help companies test from initial concept stage through to interaction with traffic. And again, it's all part of that process of making sure that when it reaches the UK roads, it's safe and secure by design, and it kind of improves our transport system. I spoke about clear regulatory pathways, so there are kind of a few exciting things happening in this area right now. So one of them is the CAV Pass project, which is a process essentially to assure the safety and security of advanced trials all through their life cycle. And so to the right, you've got the ALX system. So this is a system agreed at international level, which acts essentially like a traffic chauffeur. So it's designed to enable drivers to disengage from the driving task. So it would be a step change in terms of the technology we see on the UK roads. And government has recently consulted on it, is due to summarise the consultation responses early next year on how we deploy that technology in the UK. And then finally, in the bottom right, a summary of, the Law Commission's programme of work. So the Law Commissions of England and Scotland have been working with the UK government over the last 3 years to look at how we legislate for automated vehicles in future, including aspects, really crucial aspects like ethics, like criminal liability, and how we make sure, again, that when they come on UK roads, they're safe and secure. So this slide is just a summary of the major elements coming up. So I mentioned the Law Commission's review is due to be published in the next couple of weeks. The ALPS consultation around the traffic chauffeur system and CAV Pass, the major R&D trials. Recognising I'm running out of time, I just wanted to leave you with some final thoughts. So I think the first one is, this is a technology that comes with a lot of hype. A lot of predictions about what's going to happen when, and often they're then moved back. And I think there's a sense that develops that this is always 5 years away. But I just want to say real progress is being made. So I spoke about the ALPS system, the traffic chauffeur. That would be a first on UK roads. And I mentioned at the beginning, the Waymo trials, they now have opened a fully driverless service. So no safety driver, no driver in the car, in a 50 square mile area in Phoenix. So I suppose the point I want to make is the technology is progressing. It's getting closer to marketability. And we do need to be aware of that and prepare for it. The second point is there are huge potential benefits, social benefits like safety and accessibility of transport, and also economic benefits. And the UK is in a strong position because of the good work of government, industry and academia to date. But, and this is the final but, it will require continued support, government, industry, academia, but also local authorities and civil society working together to ensure we gain those benefits from the technology. So I'll end there. If anyone wants to learn more about this, please do contact CCAV. And I'd also encourage you to look at the Innovation is Great booklet, which was put out in the last couple of months, which gives a really strong overview of what's been happening in the last 5 years in this space in the UK.